The film you are going to see is an introduction and training film to locate insulation faults and earth faults by using BENDER search suitcases. The suitcase series consists of two basic designs: EDS3090 PG, which is used primarily in the main circuits with voltages higher than 60 volts, and EDS3091 PG, used mainly in control circuits with lower voltages. The suitcases can be used in isolated systems, IT systems, together with the pulse generator type PGH, or in earthed systems, TTN-TN systems, as a residual current monitor. The BENDER suitcase contains a measuring clamp with a diameter of 52 mm, type PSA 3052, alternatively PSA 3352. A measuring clamp with a diameter of 22 mm, type PSA 3020, alternatively PSA 3320. Pulse generator PGH 185, alternatively PGH 183. This is needed to create the measuring pulse that we should search for. Terminals and cables to connect the pulse generator to the system. The insulation fault evaluator type EDS190P is used together with the measuring clamps to search for the pulse generated by the pulse generators. Charging adapter to the measuring instrument EDS190P. Network cable to the pulse generator. Options: measuring clamp with a diameter of 115 mm, type EDS3165. This is only suitable for distribution systems. The coupling device AGE185 is to be used in IT systems together with PGH185 for the voltage between 500 and 790 volt AC and between 400 and 960 volts DC. It has been common to use simple insulation monitors with the DC measuring principle in distribution boards. These must be disconnected from the systems before using the BENDER suitcases. If there are used BENDER IRDH575 with AMP measuring principle, which has the pulse generator integrated, this is not necessary. For the purpose of a suitcase EDS3090 PG or EDS3091 PG and an insulation monitor without an integrated pulse generator, the existing insulation monitor has to be disconnected from all phases in the system. If the system voltages are between 500 and 790 volt AC or between 400 and 960 volts DC, the coupling device AGE185 must be connected between the PGH185 and earth to prevent the pulse generator to be destroyed. The pulse generator is connected to the system by first connecting the earth cable and then L1, L2, L3 as shown. In a DC system, L1 and L2 is connected respectively to plus and to minus. Basic settings for the measuring device EDS190P. To enter the menu, push menu button, which also acts as enter. The arrow keys are used to move the menu. Go into the menu settings, then push General, and choose buzzer on or off if you want acoustic signaling or not. Likewise, set the alarm LED to on or off. I∆S is set to 50 mA if used together with PGH185 and clamps PSA 3020, PSA 3052 or PSA 3165. Set I∆S to 5 mA if used together with PGH183 and clamps PSA 3320 or PSA 3352. Now we are going to set the response value for the alarm and the type of system. Go into the menu Settings and I∆S to modify the response value for alarm. Often factory settings can be used. Select AC or DC system depending on the type of system that is monitored. If inverters are connected to network, the setting for inverter should be on. Then you select the setting of the right type of a measure clamp. If you select the measure clamp PSA3022 or PSA3320, the setting in the display must be put as P20. If you select the measure clamp PSA3052 or PSA3352, the setting in the display must be put as P52. If you select the measure clamp PSA3165, the setting in the display must be put as P165. These settings are made automatically if you connect to the measure clamps before you switch on the instrument. After connecting the pulse generator, you set the maximum test pulse and start the searching for the fault location. Always start by measuring around the PE conductor that is connected to the pulse generator. The value of I∆S equals milliamps, which appears in the display, is the part of the maximum test pulse from the pulse generator that returns via the insulation fault. If this value is above the set response value for the alarm, you will be able to locate this fault by doing the following. Go to the distribution board and restart the search by taking all the phase conductors through the measuring clamp. Wait for the instrument to say it has finished the search before proceeding to the next consumer for another search for the test pulse. When the instrument displays the ΔS equals so many milliamps, you have located the fault. We make a quick replay. You should always measure around PE conductor before you start your search for insulation faults in the network to ensure that the earth fault is measurable. Then you can go into the network and look for the test pulse I∆S in milliamps. EDS3090P can also be connected to an oscilloscope. This is connected to the same plug as the AC adapter. This ability makes it easier to find a fault in those cases where there are many faults in the network. It's a risk that the test pulse is distributed in many directions and through many faults, and that the test pulse in each fault is too small for the EDS3090P to be detected. Pulse appears on the oscilloscope as a positive and negative pulse that matches the LEDs in the pulse generator. LTECO also offers training and education within our entire product range. BENDER can also provide automatic fault location with a bus solution to the overall system. In LTECO, we offer support through our own sales engineers and product managers. We help you to choose the right solutions and products. Once a year, we print an updated product catalog that includes most of our products. If you want to order our product catalog, please contact us at firmapost@lteco.no. LTECO has its own warehouse where we stock the most commonly used components for immediate delivery. LTECO is located in Porsgrunn, Norway, with offices, our warehouse and training facilities. For more information, visit our website lteco.no.